Hi all, and welcome to my video explaining the voltage divider rule, VDR. A little bit of background before we start. So to fully understand the voltage divider rule, we must first understand what Kirchhoff voltage law or KVL is. KVL states that the total sum of voltages in a loop inside a circuit is equal to 0, as shown in the example below. Also, we need to understand that the sum of resistance in a series circuit is where RT is equal to R1 plus R2 plus R3 and so on. While in parallel circuit, it's 1 over RT plus 1 over R1 plus 1 over R2 and so on. Now, what is the voltage divider rule? Voltage divider rule is a method used to simplify circuits in order to solve them. It allows the voltage across a resistor to be calculated easily, and it has the following equation, where Vx is the voltage across a specific resistor, A is the voltage source, Rx is the resistance of that specific resistor, and Rt is the total resistance. Therefore, we can use VDR to calculate Rx, Rt, and or E depending on the variables we have. For example, we have this circuit in here. We need to calculate the voltage drop across R1 and R5 using VDR. Firstly, we use our equation Vx equal E times Rx over Rt. We start by calculating what Rt is equal to. Now to do this, we can just follow the pattern here. We start with these two resistors which are in parallel, and then these two resistors are actually in series with R3 as shown in this section. Then we sum these three resistors in here in series as shown in this section. Now these two big chunks are actually in parallel. We sum them together and we add them to R1 to get what RT is equal to, which is almost 5 ohms. Now we sub our variables back into the original equation. We get that V1 is equal to 2.41 volts. Now to calculate the voltage drop across R5, we need to reconsider some stuff. Now E is not 12 anymore. E is actually the voltage source after the drop in R1, which is at this point. So it's the voltage at this point, which is equal to 12 minus V1, which is 9.589. RT is also different. RT now is not the whole resistors, it's actually just these three, the resistors related to the new voltage source, which is equal to 11 ohms. We sum everything back to the equation and we get that V5 is equal to almost 4.3587. Now this concludes the video. Thank you all for watching.